Let's try and understand negative deviation from Raoults law and positive deviation from Raoults law. Whenever we are talking in terms of negative deviation from Raoults law, we have got to focus into vapor pressure. Negative means less vapor pressure, that is lower vapor pressure, and positive means higher vapor pressure. Alright, so just focus into it, everything would be clear. Like if the vapor pressure is lowered, then the boiling point would be elevated, because we already have learned that boiling point is when vapor pressure is equal or greater than atmospheric pressure. But if vapor pressure is lowered owing to some interaction, then it would require higher temperature to generate that vapor pressure to be greater or equivalent to atmospheric pressure. Alright, so let's understand now. Now in case of negative deviation, what happens is, now there are certain interactions which we have got to keep in mind. That is solute-solute, solute-solvent and solvent-solvent. Solute-solvent in pencil, in red, whatever I have put in over here are solutes, and in pencil is all solvent. Now I've just tried to show over here all the solute particles being surrounded by solvent over here in pencil, whereas here I have not shown that. Alright, so let's understand what's the difference. Now in this case, solute and solvent, red and pencil, red and lead. Alright, these two are very interactive. Alright, so there is weak interaction between solute and solvent, but there is a strong interaction between solute and solvent, owing to which it does not leave solvent freely. It's like crab story. You keep the crab basket open, but crabs won't be coming out. Rarely crabs would be coming out, because one crab would be pulling in the other one. Whichever crab tries to walk out would pull that crab down. Alright, so no crab would come out. Alright, so even if you keep a basket of crab open, crabs won't come out. The same story goes on over here. Now this solute, since interaction of solute with solvent, solvent is more, owing to which it does not leave solvent freely even on heating. Alright, so what happens is you have to heat at a higher temperature to get that vapor pressure. So since it does not leave, so the vapor pressure is low. Since the vapor pressure is low, so you have got to heat at high temperature to get the vapor pressure equivalent to atmospheric pressure or greater than atmospheric pressure for getting the boiling point. So what happens as a consequence? Whenever there's negative deviation or whenever solute-solvent interaction is high, the vapor pressure is low, owing to which boiling point is high. Okay, it is higher than NEET solvent or pure component. Alright, so I have mentioned over here, solute is all red, solvent is in pencil. Strong intermolecular interactions between solute and solvent. Alright, now let's understand what happens. So it becomes easy for us to understand positive deviation. In positive deviation, there is weak interaction between solute and solvent. Alright, solute and solvent has weak interaction, very weak interaction, owing to which vapor pressure is higher. Alright, vapor pressure is higher, and since vapor pressure is higher, so it requires lower temperature than needs solvent for boiling point. Alright, since vapor pressure is already higher. So basically what we can say is, whenever we add such solute, the vapor pressure increases owing to least solvent and solvent solute interaction. Alright, okay.